Okay, we're ready to move on to number 10. Now, number 10, 11, and 12 all have something in common. We have a decimal in the mix. And so you might think that it's easiest to change the fraction to a decimal and work with decimals, but the problem with number 10 is that 2/3 is a repeating decimal. So we have to leave it in fraction form. So that means the negative 0.5 will have to be written in fraction form as well. So we should all know that negative 0.5 is negative 1/2. So negative 1/2 minus 2/3, we should rewrite as addition of the opposite. So I'm going to change this to negative 1/2 plus negative 2/3. And then like we were doing before, we have to find a common denominator so that we can simplify. My common denominator for these two fractions will be 6. Both 2 and 3 divide into 6 evenly. If I multiply 2 times 3, I get 6, so 1 times 3 is 3, so negative 3 over 6. If I multiply 3 by 2, I get 6, and of course 2 times 2 is 4, and that would be a negative 4 over 6. If I continue the problem, I know my denominator will be 6, and my numerators are both negative, so negative 3 and negative 4 will give me negative 7. So negative 7 over 6 is in simplest form. However, I can make it a mixed number. 6 goes into 7 once, so I have 1 and 1/6, and of course I need to bring over the negative sign. Not a lot of room here for number 10. Number 11. So again, you might think, let's make negative 7/3 into a decimal. But if I think about the mixed number, that would be negative 2 and 1/3. And that 1/3 is a repeating decimal again. So I have to keep it in fraction form. So I'm going to change the negative 0.75 to a fraction. And that's another one that we should have memorized as negative 3/4. So first I'm going to write it as negative 7/3 minus negative 3/4. So just replacing the equivalent fraction for the decimal. But now I'm going to change it to addition of the opposite. So negative 7/3 plus positive 3/4. And now it's time for a common denominator. So I'm changing my denominators to 12. And I've multiplied 3 by 4 to get 12, and 7 times 4 would be 28. Negative sign comes down. And I've multiplied 4 by 3 to get 12, and 3 times 3 gives me 9. So I'm out of room here. I'm going to continue up above. My denominator for my answer will be 12. And to get my numerator, I need to think about negative 28 plus positive 9. And I'm going to have 9 zero pairs and 19 negatives remaining. So negative 19/12, which is simplest form, but of course it is an improper fraction. So 12 will go into 19 one time, and that will leave us with 7. So 1 and 7/12, and one more time, let's not forget that negative, so we'll bring that down. Number 12 is an interesting problem. It's 0 minus 1.75. And in this case, because I don't have any fractions, I could leave this as is. I might, just to be consistent with what we've been doing, rewrite that subtraction as addition of the opposite, so plus negative 1.75. And of course, if I'm not adding anything to it, then I have negative 1.75 as my answer. And I can leave it like that, but I might also write it as a mixed number. So negative 1, and I know that the 0.75 is 3/4 in fraction form. And I don't need to do that, but it kind of goes along with problems number 10 and 11. All right, moving on to the next page. On page 40, we have a few word problems, And for these word problems, we'll have to decide if we're going to add or subtract in order to get the answer that we're looking for. The directions are to write an expression, to solve the problem, and answer in a complete sentence. So number 13 says, Ron hiked for 8 3/4 miles. After resting, Ron hiked back along the same trail for 3 1/4 miles. How many more miles does Ron need to hike to return to his starting point? So if the total was 8 3/4 and he's come back 3 1/4 miles already, then we want to subtract in order to find the distance that he still needs to hike. So for my expression, I have 8 3/4 minus 3 1/4. Now, because the denominators are the same, I might leave these as mixed numbers. And if I leave them as mixed numbers, the first thing I want to do is subtract the fraction portion. So I want to think about 3/4 minus 1/4. Well, 3 minus 1 would be 2, so 2/4. And now for the whole numbers, 8 minus 3 will give me 5. So 5 2/4, of course, can simplify to 5 1/2. And so in a complete sentence, we can say that Ron needs to hike 5 1/2 miles to get back to his starting point. Okay, not bad. Number 13. Number 14, temperatures for 5 days in Minneapolis are given in degrees Fahrenheit below. And so we see 5 temperatures. Temperatures for the following week are expected to be approximately 12 degrees lower each day than the given temperatures. So 12 degrees lower means we're going to subtract 12 from each. However, they only want us to find the highest temperature and the lowest temperature expected for the corresponding 5 days next week. So I have to look at that list of 5 temperatures given, and I have to pick out the highest and the lowest temperature. So the lowest temperature will be the farthest from 0 on the left, of course. So we've got negative 22.5, which would be negative 22.5. And we have negative 22 2/5, which would be negative 22.4. So actually, this negative 22.5 would be farthest from 0 on the negative side. So that is the low temperature that we've got to work with. So the low temperature, negative 22 1/2. Okay, there is also a high temperature in that list. So the high temperature would be the one that is closest to 0. And I'm looking at negative 19 3/5, which would be negative 19.6, and negative 19.5, which is negative 19.5. So closest to 0 would be negative 19.5, which would make it the high temperature. So if the temperatures the following week are supposed to be 12 degrees lower, then from each of these I want to subtract 12 degrees. And if I do that problem, I will have the low temperature and the high temperature for next week. Because I have subtraction from a negative number, I'm going to rewrite it as negative 22 1/2 plus negative 12. And for the other expression, negative 19 1/2 plus negative 12. Now, if we think about it, both numbers are negative in each of these expressions. So for a chip model, I would not have any 0 pairs. In other words, I'm combining all of my negatives. So for the low temperature, if I combine the two whole numbers, that's going to give me negative 34. And of course, I have the 1/2. And for the high temperature, if I combine my two whole numbers, 19 and 12, that's going to give me 31, so negative 31, and of course the 1/2. So now I can put a sentence together with the high and low temperature. So we'll say the low temperature will be -34.5 degrees Fahrenheit. The high temperature will be -31.5 degrees Fahrenheit. And we have made it to the last problem, number 15. A football team loses 4.5 yards on their first play. On the next play, they gain 2.5 yards. What is the overall increase or decrease in yards? So because they lost 4.5 yards, I'm going to represent that with a -4.5. And then because they gained 2.5 yards, I'm going to add a +2.5. Okay, now I have a negative number and a positive number, so I know there are going to be 0 pairs, and it's a little bit harder when I'm working with mixed numbers. Again, like I said on the previous page, we could leave these as is, or we can make them improper fractions, which I think is the easier way to go. And then, like I said earlier, once we get a better idea of what's going on, we can try working with the mixed numbers for problems like this. But I'm going to make these improper. So 2 times 4 is 8, plus 1 more is 9, which means I have -9 halves. And for the second mixed number, 2 times 2 is 4, plus 1 is 5, so I have +5 halves. Of course, my denominators are the same, which is nice. So denominator will be 2. I have 9 negatives and 5 positives. So that will leave me with 4 negatives. And -4 over 2 is improper. And 2 is going to go into 4 twice evenly. And of course, I need that negative sign. So -2. The question is, what was the overall increase or decrease in yards? Because we have a -2, we know that there was an overall decrease of 2 yards. So we can say in a complete sentence, there was an overall decrease of 2 yards. And that's that. You're going to follow this with the homework assignment 2.3b, which is due on Friday. Remember, on our homework assignments, we try every problem, we use pencil, and we use our notes. So when you're working on the homework assignment, I want you to have your module open to pages 39 and 40 so that you can see all of the examples that we've just done together. Okay, if there are any questions on this homework assignment or 2.2b from earlier this period, you can come see me after school today. I will be back, or before school tomorrow, or after school tomorrow, so that you can get questions answered before the 2 assignments are due. And both assignments, 2.2b and 2.3b, are due on Friday.